Alright, today we are multiplying binomials. Now this is a double distribute, so a binomial has two terms, so we have to distribute two things. Some people call this FOIL, and let me show you why they call it foiling. You've got FOIL is an acronym, it stands for first, outside, inside, and last. So you can call it either double distribute or foiling. So right here I've got a binomial times a binomial. So the first thing you do is you distribute the first term. So that's why it says first, because it's first to first, and then outside to outside. So that's the F and the O of FOIL. So first to first, first to outside. So let's go ahead and do that math real quick. 5x times x is 5x squared. So that 5 goes out in front. X and x make two of them. 5 times 6 is 30. With that x tacked on right there. Alright, now you got to switch over and you got to distribute your second term. This is why it's called the double distribute. You got to distribute twice. So we do the first one on top, we always do the second one on the bottom. So we say positive 3 times x is positive 3x. Positive 3 times 6 is positive 18. So let's see what we just did there. We did inside to inside, so 3 to x, inside to inside. Inside to last, so there you go. Your FOIL has all been written out for you in that order. You have always one other step to, or nearly always one other step to this FOIL, and that is these like terms that show up in the middle. You get 5x squared, 30x and 3x make 33x plus 18. So nearly always these binomials and binomials make a trinomial, nearly always. Alright, let's try our next one right here. X times x is x squared. X times negative 4 is negative 4x. And we'll switch down to the bottom here. Positive 1 times x is positive 1x. And positive 1 times negative 4 is negative 4. So again, like terms right there in the middle. So we've got that x squared, negative 4 and 1x make negative 3x. And then minus the 4 at the end. Done. Two more problems. This next one is called our difference of squares. You'll see why when we finish it, but notice what we have here. A term, almost the exact same term, the only thing that changed is plus to minus. So I say 4a times 4a is 16a squared. 4a times negative 1 is negative 4a. Positive 1 to 4a is positive 4a. And a positive 1 to a negative 1 is a negative 1. So when we go to combine like terms this time, they actually cancel because it's positive and negative, the same thing. So all I have is 16a squared minus 1. I want you to notice what that answer really is. It's your first term squared minus your second term squared. So difference of squares. So there's a subtraction between the squares of your numbers there. If you can notice that pattern, you can skip all the work in between and just give me that final answer. Alright, this is another special pattern. So if you see this lovely squared here, it means that I have this twice. What I don't want you to do is just to give out that squared like before. We used to do that through multiplication. Like if this was 4x squared, we could give it out throughout that because it's all multiplication and exponents are also multiplication. Because we have this addition in here, that's really going to mess up all the operations going in inside. So if you have a squared outside a binomial, just write it twice. Now you've got to FOIL it. So x times x is x squared. X times 4 is 4x. X times 4 again, 4x. And then 4 times 4 is 16. So we get to go ahead and add these together. We get exactly the same thing in between each time for these squared ones. So I get 8x plus 16 plus x squared up front. So there you go. This is a special pattern. So what you can do is you can square the first one if you like. Do double that second one times the first one. So I said 2 times 4 times x. And then square the second one. Again, special pattern. You don't have to use it. You can just show the work in between if you prefer. Alright, that's everything about foiling.